right. Well, thank you very much, and welcome everybody to my talk about how to not pull your hair out while providing data to the business. We're going to talk about unit testing data pipelines, and seeing the crowd, I think at least everybody has pulled once out their hair while doing so. So nice to have you all here. Yeah, indeed, I'm one of the co-founders and data engineers at Blend Data. We build data pipelines for our customers, and yeah, today I'm going to tell a little bit about what we have learned during all those journeys. So, what to expect today? First, I'm going to talk a little bit about automated software testing, what it is and why you would want to use it. Next, some theoretical background about testing, so what it conceptually is. Next, we're having a practical example using beer. I thought that would be a nice use case for the audience. And finally, I have a recap where I have some practical examples on how you can use it for your projects that you do on a day-to-day basis. First of all, I'm a little bit interested how the audience is put together. So I'm interested in who is a data scientist over here, who is a data analyst, okay, data engineer, also plenty of you, and software engineers, also a few. Nice. Okay, I think for everybody in there, I have some examples that you can use because it will mainly focus on Python, but you will see that in a few slides. All right, so first of all, why automated testing? Automated testing is a principle that comes from software engineering, and it helps you in delivering products that actually do what you expect them to do. So here I have a very trivial example, a Python function that just adds 1 to a number and then returns it back. Well, you can write some tests for that. It helps you making more robust code, but it also helps future you, so you can see the test and see what it is expected to do. So here I have created a very simple test. One test case enters 4 into the function and then 5 comes out, and one test case enters 5 and then 6 comes out. Well, this is very trivial. You probably wouldn't use that in your projects, but it shows the ID. Then you also have a testing framework, and what a testing framework is some piece of code that runs the tests on the right side and checks whether all your so-called test cases succeed or fail. When they succeed, they are green, and otherwise they are red, which you will see later on. Okay, so after this practical example, more about how tests will work in general. And I think that's nice to know in order to apply it to your data pipelines. So to make it more mathematical, we can describe a test as y equals fx. And f is in this case your Python function, x are your inputs, and y is the output of your Python function when you have put x into it. And when you have a test, you check that the actual output, so your y equals some certain y that you expect up front. So how can we apply this theoretical model to an actual data pipeline? We have the same equation, however, for our inputs we use a data frame, and that could be any type of the data frames that you might have seen in the talks this morning, but you could use Pandas or PySpark, for example, to use that. And as the outputs, you also have a data frame, which probably would be the same type as you have put into it. So how can we apply this model to beer? To make it more concrete, we are tasked with a specific task, and we need to provide the business with insights about the most popular beers that we have within Eindhoven. so we can create as a company profitable and very tasty new ones. So in this example, I'm going to retrieve some data from Untapped. I think many of you are familiar with that app. I have made a Python script that retrieves the data from the Untapped page, processes with the logic that our business wants, so grouping the beers by a specific category, and then aggregate some ratings about the beers. And then it's written to a CSV file that contains all the insights that we want to know. So how does the code look like? Here I have an example. I can imagine it's not very readable for everybody, so we can zoom in a little bit. And it's not our final code, but something we are start with. And it's not necessary that you know all the details, but I will walk you through high over. So first what we do is we loop over all breweries we have in Eindhoven. Then in the second part we parse some information about the beers. And a little bit below halfway we do some processing on the data to make it possible to do some aggregations on it. And then finally we group the beers by their specific style and write it down to a CSV file. But how is this testable? Because it is a long script, also not very readable and also still hard to test. So in order to do that, we're going to walk to a 5-step process together, and in the end we have a working test that validates our code. But first what we are going to do is define our fx. So what is the function and what should be the corresponding inputs and outputs. Then we're going to refactor our code, so split it up into multiple parts that are both testable and more readable. As a third step, we're going to generate some synthetic data. Then we're going to create the actual test in PyTest. And finally, I'm having a bonus tip for you where you can even automate the checking process even further. Okay, so here we have our script, but does anyone do a guess about what our fx function would be in this case? There's currently one function before refactoring, but we're looking for the fx part where a data frame is inputted and a data frame is outputted. Yeah, indeed, the comment gives it away a little bit. The part that is over there, that is the actual fx in our Python script. So let's refactor it into something more readable, and then we end up with this code right now. On the top we have the extract part. That is the part that retrieves the data from Untapped and puts it into a data frame. The second part really contains all the Pandas logic in order to create something readable from it. And the final part is writing to a file. So then the next step is generating some synthetic data. Well, why do we need to generate some synthetic data and not just use the Untapped web page? Because it's already there and the code is already working, right? Well, a unit test prescribes you that you should have no external dependencies. And what are external dependencies? External dependencies are systems or external parts that your code interfaces to in order to make it work. And going to the Untapped web page is an external dependency because we have our Python code living over there. We need to make a request to the Untapped web page, and then maybe the Untapped web page is down and it returns an error. And then our Python test will fail. But this gives a wrong insight because right now we could have the idea that our own Python code is not functioning while the actual problem is with the network. So we want to remove out those dependencies so we only validate that our internal code is actually working. And in order to do that, we need to create some synthetic data. So if we go back to our initial function, we have to think about what does the input data frame look like and what is the structure of that, and what does our actual output data frame look like and what is the structure for that data frame. Alright, so I've already ran the code for you, and we're going to look how these data frames should look like. In this case, I've picked the Rabau brewery. We have 3 types of beer that we are going to process, and as you see, we have 6 columns with the name, the style, the alcohol percentage, the ratings, and the number of ratings it has. Well, some parts, they all contain strings, some parts contain percentages. It's important to know this about your data structure that you will use as an input, because your synthetic data that you will use also needs to have the same characteristics. Okay, so now we know this for our input data frame. We can have a look at how our output data frame should look like. Well, our output data frame just has 4 columns, only with the styles without the subtypes in them. They all contain numbers, and they are all floats in this case, or decimal numbers. So, okay, now we know these characteristics. How can we then create them for our test? Well, there are many ways to do that, but the easiest is to implement that in pure Python directly, because your tests will also be in Python code. Here I created a data frame from a Python list, and here we see that is not the actual data, but something that we have come up with. In this case, we used 2 beers that are brewed by Blend Data. We're not an actual brewery, but in this case we can use that for our test. We have an IPA and a stronger and a lighter beer. And we have our expected data frame that just contains 1 row and the averaged results that are a decimal number in this case. Okay. The next step is installing PyTest. And why are we going to use PyTest? Well, in the beginning of the talk I mentioned that we need a test runner, and PyTest is one of the test runners that is compatible with Python and is apparently one of the most used, so we're going to stick with that one. Then we need to change our folder structure a little bit where our Python code is in order to make PyTest work. And this is what we finally end up with. The bottom file is the file we just refactored, and on the top we have a folder with tests that contains an empty init file and a test1 file. Okay, so now we can create a test, and that will look something like this, and I'm going to walk you through what happens in this file. On number 1, we input the transform function that we had refactored out, so that contains all the logic for processing the Pandas data frame. Then in step 2 we create a function in our Python file that starts with test. That means that it is a test and will also be picked up by PyTest. Then at 3 we create the synthetic input data frame that I've shown you on the previous slides. On step 4 we do an actual call to the function that contains our business logic. And in step 5 we create our synthetic output data frame. And then in step 6 we execute the actual test. In this case I'm making use of the Pandas testing module. That's an helper module that helps you to compare your input data frame and output data frame and shows you the results in order to give you some information that could help you for debugging. When they are equal, it does nothing, and when they aren't equal, it will raise an error and your test will fail. Okay, so now I've created the test and I can run it with a simple command pytest, and then it will show you that our test is green and everything is nice. Yay! Hopefully, at least. Because as you remember, the business wouldn't be the business if they came with a new question about our data. Well, nice Lars, but we have 4 tasting locations in Eindhoven and not just one. And then I'm like, yeah, I know, give me a minute and I will fix it for you. So what I try to do, I try to create some code so it's modular and easily extendable. So I will add the other breweries we have in Eindhoven and everything will be fine. Is it? Well, not exactly, because here we have a new type of beer that isn't processed correctly in our data pipeline. It's specifically a non-alcoholic beer, and it ends up in our final data frame as such. Well, I don't know about you, but for me it's not really clear what this type of beer is. So we have to change our initial implementation in Python. Well, in order to do that, we first create a new test case, because our initial test case apparently didn't cover this type of data. So we need to create a new test case that facilitates checking whether this works or not. And it looks very similar to the previous test. However, the only difference is on the top, where I define our synthetic input data, it now contains also the string non-alcoholic IPA that apparently isn't working properly in our current code implementation. But what I expect it to be is that there you see it on the bottom part. It should contain non-alcoholic and then the values we expect. So now I have created the test, I can change the implementation in Python. And if I look in the code, I found that those 2 lines of code are actually where the problem arises. So after some fiddling and after some trying, I end up with this alternative. Instead of using split, I'm going to use rsplit, which separates the style on a different location in the text. So now I can run pytest again in order to validate that it has worked, and oh, it didn't. So right now, before I already deployed this code and delivered the result to the business, I have catched errors up front. So it gives me an error message about what has ran wrong. So in short, it says you have 2 records in your output data frame instead of 1. Well, what might have gone wrong? This is the test case that has gone wrong, and maybe few of you already spotted that I made a mistake in our change of the code, because currently it doesn't process these 2 records correctly. It doesn't strip out all the spaces, and that's why we end with 2 lines. So what I can do, I've added the bottom line, and then I can run pytest again, and as you will see, everything is fine now. So right now I didn't have to pull out my hair where the business was coming back, hey, the regular beers aren't working anymore, because I've catched this problem by running tests before deploying my solution to the business, so to say. So right now we are ready to release. But I still have a bonus tip for you, because right now it really depends on your team and how eager they are to run pytest before deploying this to the repository or before delivering the value to the business. So how can we automate that part as well? You can run that in CI, and I'm not sure who of you is familiar with what CI is. Can I see hands who does know what it is? All right, cool. Plenty of you, but for those who don't know, I will explain. CI is a kind of automation process that you can run on top of your Git repository in order to do some checks on your code base. And you can often customize that yourself about what that does. For GitHub, you can use GitHub Actions, and for GitLab, you can use GitLab CI. And for Azure DevOps, you have Azure Pipelines, which you can use. But the process looks as follows when you use CI. Often your implementation of code that is working is on the main branch, and when you want to add a feature, you often create a separate branch for that. And in this case, all the dots are the commits on the specific branches, and here you see that on the first commit, CI has ran, and in this case the CI failed. So when you have PyTest, which you can run in your CI, then your CI checks out your code, runs the PyTest checks on your repository, and then reports the result back. So in this case, you can you often do that while running on a pull request. So if you right now create a pull request from your feature branch to your master branch, you will see that on the first commit the CI has failed, on the second it has failed, and finally after some changes to make it working, it was green. And you can also automate this process in order to prevent that wrong code is merged into your main branch, because you can disable merging of your pull request if the tests are not succeeding. To make it concrete, this is an example of GitHub Actions where you can run a test on your pull request. In this case, the merge pull request isn't disabled, but you can make this button grayed out if your tests are failing. Alright, a short recap how you can make your data pipelines more robust using tests. First, think of what is your actual FX, so what is your Python logic that contains the business logic. Then refactor your code so that this part of your Python code is also an actual function. Then you need to generate some synthetic data to make it testable. Then you create a test, and finally I would recommend that you create a process in your CI in order to automate this part. Alright, these are the basics. For those of you who are maybe already familiar with that, there are also some steps that you can take it to even a higher level. Today we only talked about unit tests, and unit tests are the so-called bottom of the testing pyramid. For those of you who aren't familiar with that, this is a testing pyramid, and the width of the pyramid stands for how many tests you have, and the height stands for how complex they are. So unit tests, you often have a lot of them which are not so complex. They are also often easy to run, but you often run your Python script somewhere, maybe in Airflow or maybe in a serverless kind of environment, and then you can create more complex tests that also take into account the runtime of Airflow or your serverless environment. Or maybe you can also take into account the process of talking to an API or the untapped web page. A book that has helped me at least to become more confident in that is Architecture Patterns with Python. It's not necessarily a data science or a data engineering book. It's more focused towards software engineering. And today we also used Pandas, but if you're using Spark, for example, you can use the data compile package in order to do your asserts on PySpark data frames. Well, if you want to have a look at the code examples used today, you can look at my GitHub, and that's it. Thank you for your attention.
Thanks for your talk, Lars. Any questions from the audience? One in the back.
Thank you for your talk. Oh. Can you still hear me? Yeah.
Yeah.
I have to keep it close. So what I ended up doing as a data analyst, that I wrote 200 lines of code, and then in the end oh shit, I have to do tests. And then I got stuck at, do we have to write like one single test. I know like a unit test, you typically want to do one single piece of code, but with data, like every line is a single transformation. So I was wondering if you have some good practices or rules of thumb, how you decide on like when do we have to make like a new test or like split the code and have like, I have this test, I have test 1, 2, 3, 4, 5 on your code without having like for every single function a separate test.
Yeah, there's, I think, no exact science about how to do that. What at least me helps very often is, this wasn't maybe the most proper example about how to write clean code, but for demo purposes, I think it is fine. But in other cases, it's often a good idea to group some kind of functionality that either does one thing together in a function. And when you have 200 lines of code, I can guess that it's not one function, so to say. You can probably break it into 10 or maybe 20 functions that do something, and then it would be wise to test each individual function. Because also the more often the longer is the actual code that you need to put under test, also the more complex the inputs and outputs that you need to set up in order to make your test testable, so to say. So breaking it up in multiple functions also simplifies writing tests for that. So it's also a little bit of experimentation, but I think writing smaller functions also helps you in writing easier tests and also spending less time writing them.
Okay, thank you.
Any other question?
Thank you. Previously, thank you for the talk, of course. And previously, when I used some testing with Pandas, I stumbled into null values that are like one, and like numpy na is not equal to another numpy na, right? Which makes Pandas data frames that contain null values not equal to each other, even though they are actually equal. How do you usually solve that problem?
It actually depends, because when you create your data frame, you can either enter, I think, null values or non-values, but also the testing module of Pandas itself, it gives you some options about how specific it should be on whether those two frames should be equal or not. Should it be all values, or should it be the whole data frame, or is it allowed that indexes are different, or is it also possible to allow that data types are different in the sense that it would be an int 8 or int 16, for example. You can tune your input data frame, or you can tune the settings for the Pandas testing module.
Thank you.